Welcome to July's LeetCode Challenge. Today's problem is find peak element. A peak element is an element that is strictly greater than its neighbors. Given an integer array nums, find a peak element and return its index. If the array contains multiple peaks, return the index to any of the peaks. You can imagine that the first and last element in our nums is equal to negative infinity. So you must write an algorithm that runs in log of n time. So essentially, we can see that, well, first off, all the numbers are going to be either ascending or descending. You can see that here in this constraint. And we want to find one of the peaks inside of our number. So like the easiest way to do this would just be to do a linear scan, right? We just go through every single number. And as soon as we find that it's descending, we ascend, and then there's a descending point, we know we found at least one peak. But we want to do this in log of n time, right? We don't want to do it linear. So the way that you could figure this out, just given this example, say that we did a binary search and we want to just find the middle and see if the next number is ascending or descending. Here, let's give another number here, say like -1. Here we start with the middle, right? 3, and we want to check the next one to see is it ascending or descending. Here we can see that it's descending. What that means then is if we find that at this point we're descending, a peak must have existed on the left side, right? Say that this was like 4 though, or 5. Then if we see that it's still ascending, that must mean the peak still must be on the left side here, or right side now. So there could be multiple peaks here, but it doesn't matter which one we select. We just want to find one of the peaks, right? So that's what we'll do. We'll just do a binary search to see are we ascending or descending at this point, and then check to see that side and continue on until we find one of the maximum peaks here. So it's a pretty classic problem. What we'll do is first have a left and right pointer, 0 and length of nums, -1. We'll say while L is less than R, let's calculate the mid, which is going to be L plus R divided by 2. And all we want to check to see is, are we ascending or descending at this point? So if mid, or I should say nums mid, if this is, let's say, less than nums mid plus 1, that means we should be checking our the right side, right? So this would just be what? L would now equal to mid. And I believe we need to add a 1 here, mid plus 1. Otherwise, we're going to move our R pointer to the mid here. And then we just return the index point, which would be the L. So let's make sure this works. Okay, it looks like it's working. Submit it. And there we go. So that's accepted. Time complexity is going to be log of n, and we use constant space. So this is a pretty classic problem. It's basically a modification to our binary search algorithm, and it's actually one that I've just learned before from a lecture. I think it'd be pretty hard to come up with on the spot, but given that we know that we want to solve it in log of n time, we must know that there's some sort of binary algorithm going on here, right? So I believe if you play around with it, you can eventually get it. All right, thanks for watching my channel. Remember, do not trust me, I know nothing.